Okay, this is the Law of Sines 8.1 part 2. Let's try to handle the case 2, where you are given two sides and an angle. Remember, this is called the ambiguous case. So what you are given is two side lengths and the measure of an angle opposite one of the sides. So you have little pictures that might look like this. You're given this side length B, side length A, and you're given the angle opposite side length A, so angle A, or something like this. Remember that right now I'm not drawing the complete triangle because for all we know, such a triangle does not exist. All right, so let's see. If the angle that's given is acute, then we are going to have four scenarios to consider. Yeah. So remember, acute just means less than 90 degrees. So let's think about the scenarios. So imagine that you were given side length C, side length B, and the angle opposite side B, so the angle B. All right, what you're going to want to think about is imagine trying to find the height of this triangle. So I'm kind of, this height, I'm calling it H. It's this vertical line. It's supposed to be perpendicular to this horizontal line here, which I guess I'm considering my base. So let me think about how can I get a hold of this height. Well, think about this right triangle here on the left. What I can say is that sine of B is equal to opposite over hypotenuse. So sine of B is H over C. And then I just solve for H. So that means multiply both sides by C. And there I go. I have an expression for the height, C sine B. You're going to want to be doing this quite a bit. So that's why I've circled it here. You might want to refer back to this. You're going to want to compute this height here to determine how many possible triangles you can form. All right, so let's see. We're considering, so right now the angle that we were given is acute. We found the height or the theoretic height of this triangle. And now we're going to have to do some comparisons of lengths. If side length B is smaller than H, so if this side length here is smaller than this theoretic height, then no triangle is possible, because that means that this leg right here, the leg of this triangle, is not long enough to close a triangle. So in that case, we have no triangle. Nothing can be formed. It doesn't form a triangle. All right. So let's consider the next scenario. You are given side length B. You're being given side length. So you're given side length C, B, and the angle opposite one of them. So angle B. You have to compute the height in the same form as before. So height in this case is going to be C times sine of B. If the height is exactly equal to B, then you're dealing with just one right triangle. All right, third scenario. The third scenario is where you are given two side lengths, again, an opposite side, and in this case, side length B is just bigger than side length C. So the side length that's associated with the angle is bigger than the other side length, then only one triangle exists. Now comes kind of the tedious case. All right, so let's consider now what's happening here. So now you have been given side C, side B, and angle B. You gotta compute the height. So you compute the height as before. Now, if B, the side B, is bigger than the height, but the side B is smaller than the side C, then we're going to have two possible triangles. I've sketched, this picture right here is kind of crowded, but I've sketched the two possible triangles over here. So this is one of the triangles. I'm going to call it A2, B, C2. And you can sort of see it over here on the left of this picture, A2, B, C2. The other triangle, I'm calling it A, B, C1. And that's just the bigger picture here. So A is, well, this big angle over here. B, that's what was given to us, and C1. Those are the two triangles that could possibly result from this information. One thing to notice here is that there are these two supplementary angles, C2 and C1. Once you find either C1 or C2, well, they add up to 180 degrees. So once you have one, the other one is a freebie. This is going to be a tedious case, and we'll tackle it here in a second. All right, what if the angle that's given to you is obtuse? Then life gets a little bit easier. The first picture looks something like this. So there's only two scenarios now. So if the angle to you that's given to you is this angle B is obtuse, you're given the side opposite that angle, and you're given some other side. If this length BC is bigger than B, then no triangle is possible. And if you're given an obtuse angle and the length B is bigger than the length C, then only one triangle exists. All of the exercises that we're going to be doing here in a second deal with acute triangles. That's the more difficult case. But I thought I'd mention obtuse angles as well. All right, let's get into an example here. So the instructions go as follows. If possible, solve the triangle ABC. If more than one triangle is possible, solve all of the triangles, solve both triangles. And the information given to us is that the angle A is 60 degrees. The side opposite the angle A is 9 inches. So side length A is 9 inches. And we were given another side length C, which is supposed to be 10 inches. At this point, you might want to pause the video and give yourself 10 minutes, 15 minutes to try to see if you can come up with the answer to this question. Maybe one triangle is possible here, maybe two triangles, maybe no triangles. Then just check back on the video. All right, so I'm going to solve it. I'm going to solve it. Let's get on with it. What I would do with pretty much any of these problems, it's begin by sketching a little picture. I think it helps me start organizing my information. So I've already sort of sketched this little picture here of the information that was given to me. So the angle A was given to me. I was told that it's 60 degrees. The side opposite is 9 inches. And then I was also given this other side, which is supposed to be 10 inches. Okay. I'm going to compute the height. I'm going to compute a height because I'm going to have to think about the scenarios. Because remember, right now I have an acute angle, and there could be possible 4 scenarios here to consider. All right, so I'm going to say sine of 60 degrees. So I'm looking at this right triangle right here. And I'm thinking, okay, sine of 60 degrees is opposite over hypotenuse, so h over 10. And let me solve for h. All right, so if I solve for h, I end up with, well, the exact solution would be 5 root 3, because sine of 60 degrees is square root 3 over 2. Or if we punch this into our calculator, it's about 8.7. And I guess right now we're dealing with inches. I mean, this is a length, a height. Let's agree to keep our calculator in degree mode. And let's round to the nearest tenth, both angles and side lengths. All right, so what's going on here? So our height is 8.7. So our height is smaller. So my height is smaller than A, because A is 9. And A is smaller than C. So I have a situation where A is bigger than H and C is bigger than A. That's corresponds to 2 possible triangles. So 2 possible triangles can come out of this information. Now we need to visualize how do these 2 triangles kind of look like. And well, I've sketched them here a little bit of how they could possibly look like. And these are the 2 possible triangles that we can form here. So you have this triangle where you have angle A being 60 degrees, you have the side opposite is 9, the side C is 10, and over here we're going to have this angle that I'm calling C2 in green. Notice that this angle C2 is obtuse, yeah, and then we have, I guess, an angle B2 and its corresponding side length B2. That's one of the possible triangles that can come out of this. The other possible triangle that could come out of this is, well, we have angle A, 60 degrees, its side opposite is 9, this side length is C, and then we have this other possible angle, which I'm calling C1, and notice that this C1 is acute. And remember, there's a relation between C2 and C1. They're supposed to be supplementary. If you add them, the sum should be 180 degrees. And I just noticed we need to call this little guy here B1. We need to call this B1 just to be consistent. Okay, so these are the two triangles that we're going to have to complete. Alright, so let me try to begin completing them. So which one do I begin with? Which one do I begin with? To be quite honest, I really don't know. I really don't know. I don't know if I should solve, I don't know how I should start this. But let me just think about the information that was given to me. I have this angle and the side opposite. So I can start thinking about the law of sines. Because I can say sine of A over A equals sine of something over something. And well, think about it. I was given side length C. I was given side length C. So I could maybe start trying to find the angle C1 or C2 because I know side length C. Whereas I would not want to start playing with angle B or side B because I have no information about either of them. So I think my first step here is to try to solve for either C1 or C2. So let's see. Let's solve for C1 or C2. Which one? I guess I don't know. I really don't know. So what I'm gonna do is, instead of trying to solve for C1 or C2, I'm just gonna go about it a little bit blindly. I'm gonna go a little bit blindly. So I'm just gonna start using the law of sines. So I'm gonna say sine of 60 degrees over, oops, let me change back to red. Sorry, used to be consistent here. So I'm gonna say sine of 60 over 9. So sine of A over A should be equal to sine, I don't know if I'm solving for C1 or C2, so I'm not going to call it either. I'm just going to say sine of C over 10. Yeah, so let me try to find C, the angle C. So in order to find the angle C, I'm going to first multiply both sides by 10. So I have that 10 times sine of 60 over 9 is equal to sine of C. Okay, now how do I get a hold of just C? Well, I'm going to have to take sine inverse, arc sine. So let me do that. So sine inverse of this big expression here, 10 sine 60 over 9. That's what C is going to be equal to. Yeah. Now, which one am I going to find? C1 or C2? Well, let's think about sine inverse. If you remember, sine inverse has a range of negative pi over 2. Oh, that's a horrible pi. Sorry, I can do better. Negative pi over 2 to pi over 2. So that's quadrant 1 and quadrant 4. Well, right now we're looking for an obtuse angle or an acute angle. And remember, sine inverse gives you things that end up in quadrant 1 or in quadrant 4. So which one do you think we're going to end up finding, C1 or C2? Well, let's see. I don't know. I'm going to use my calculator here. Now I got to be careful with my calculator. I want to make sure that it's definitely in degree mode. And let me go ahead and enter this into my calculator and see what I get for C. So I'm punching things into my calculator. Okay, there we go. I get the following. I get 74.2 degrees. It's approximately equal to C. Yeah. So what have I found? I guess what I have found is C1. Yeah. So I have found C1. So let's say that. We found C1, which we're denoting in black. And C1 we said is about 74.2. My 4s look like 9s. Let me correct them a little bit. Jeez. 74.2 degrees. Okay. So if I know C1, C2 should be easy to find. So C2 should be equal to 180 minus C1. And well, that's what? 180 minus 74.2, that's 105.8. Yeah? Okay, so let's go back up here. So right now we have found C1, we have found angle C1, and we have found angle C2. Now it kind of gets easier. Now it's we have two angles now. It's easy to find the third one, and now it's just a matter of using the law of sines. So let's just complete one of these triangles. I'm gonna complete the C1 triangle. Yeah, I'm gonna complete the C1 triangle. So let me see. I wanna just kind of copy it. Let's see. I'm gonna see if I can copy it, and I don't wanna sketch it again. All right. So how do we copy? Let's see. Copy, and let's paste it down here. So let's agree to solve. Let's solve the C1 triangle. And let's paste it somewhere down here. I think what we have to do is say, there we go. All right, so that's the C1 triangle. Let me move it right there. All right, good. So let's continue solving this triangle. So we know that C1 is, what did we say C1 was? 74.2. So this is 74.2 degrees. And let's just kind of continue with this triangle. What would be the next reasonable thing to start thinking about? Well, maybe let me find this angle B1. So I know that C1 is 74.2. So then B1 is going to be 180 minus the sum of 60 and 74.2. All right, and that tells me then that B1 is 45.8. So I know B1, yeah? It's 45.8. So now, let me find, so let me put a little line right here just so that, yeah, we go. So we found B1. Let me find the side length B1. All right, in order to find side length B1, I'm definitely going to have to use the law of sines now. So I'm going to say, that sine of 60 over 9 is equal to sine of B1, which we know is 45.8, over, well, this length B1. And let's solve for B1. So here what I would end up concluding is that B1, if you do this correctly, B1 is about, I'll let you verify here the details, it's about 7.5 inches. Yeah? Okay, so we've concluded, we've completed one of the two triangles. One of the two triangles we've completed. We've completed this, this one right here. We've completed that one. Now, we still need to complete the other one. What I'm going to tell you is just what the dimensions are. So for this other one, we need to find B2, C2, and the side length B2. And let me just tell you what they are, and check your work, and hopefully we agree on this. For the other triangle, we have that B2. Well, we know that C2 was 105.8. We concluded that earlier. B2 then is 14.2 degrees. And side length B2 is 2.8 inches. All right. So check your work. Hopefully we agree on this. This is the most tedious work here. I mean, for the second, in order to complete the second triangle, I had to use the law of sines and I had to do a little bit of work. But for the sake of time, I'm just telling you what the answers are. You check and let's see if we agree on this. Yeah? All right. So let's move on to the next example. We gotta solve triangle ABC if angle A is 40 degrees, the side opposite is 16 centimeters, and we're given another side 9 centimeters. So I'm gonna sketch the picture here. And well, first of all, kind of what we have is this. Let me begin by sketching the little picture here again. Pause this video at this point and take about 10 minutes to see if you can come up with a solution to this problem. Do it. Take advantage and exercise and practice this information. All right, so let's see. Right now, what I know is, well, the picture sort of looks like this. So I was given this angle A, which is supposed to be 40 degrees. I was given the side opposite, which is 16, and then I was given that B is 9. And what you need to notice here is that the side opposite, so this side opposite is definitely, the side that's opposite the angle is definitely larger than B. So right now we have that scenario where B, yeah, and so we have only one triangle. Since I know that this is going to be one triangle, I can actually maybe then just sketch it out what it looks like. It looks something like that. All right, so that means I'm gonna have to find this angle B. I'm gonna have to find this angle C and side length C. All right, what should be the first thing that you find here? What should be the first unknown dimension that you should go ahead and try to find? I hope that you agree is that the first thing you're gonna have to do is find angle B. Yeah, the first thing you're gonna have to do is find angle B. You're gonna have to say sine of B over 9 is equal to sine of 40 over 16, and you're gonna have to solve for B. So you're gonna have to take a sine inverse eventually. You're gonna have to play with arc sine. So make sure your calculator is in degree mode. And well, I'll let you continue the work here. I'm just gonna tell you here what the answers are supposed to be. So what you should conclude from this problem is that B is supposed to be equal to 21.2 degrees. Angle C should be equal to 118.8 degrees. And side length C is 21.8 centimeters. So hopefully you agree with me. And yeah, there's a few intermediate steps here that I'm not gonna go through. I mean, a lot of the stuff that we've done in this previous example up here and in the previous section are the steps that you need in order to find these dimensions. What you gotta kind of play around with right now is determining how many possible triangles you can complete. That's thinking about these scenarios. And remember, right now, all of our angles are acute. All right, the last one. Last example. Again, pause the video, try to do it on your own, determine how many possible triangles you can make out of this, and try to complete them all, if however many you can make, 1 or 2. All right, so let's see. Let's at least set it up. So the setup of this problem, it's like this. I have my angle 86 degrees. I have that this is 14, the side opposite. And I know they told me that B is 25 inches. Okay, I gotta compute height here, h. And if you compute the height h in this particular example, so h should be equal to 25 sine of 86 degrees. And if you punch that into your calculator, making sure that your calculator is in degree mode, that's 24.9, I guess, inches. And right now, then we're dealing with a situation where the side opposite, so the side opposite my angle, this side, is smaller than the height. So what we can say here is that A is smaller than H, so no triangle. I like that. I like it when there's no triangles. Good. That's all there was to that one. Okay, let's switch gears here for a little bit. Let's talk about the last topic in this section. Finding areas of triangles. All right, so how do you find the area of a triangle? Well, from geometry and from, middle school and elementary school, we know that the area of a triangle is supposed to be the base times the height divided by 2, or 1/2 base times height. Not a difficult formula. A lot of us know this formula. The thing about this formula is that sometimes it cannot be used because we do not know what the height of the triangle is. I mean, if we're dealing with a right triangle, it's easy to know what the height. But if we're dealing with an acute or an obtuse triangle, then who knows what the height is? But we know enough trigonometry at this point that we can compute a height, if we're given enough information, I guess. So consider this acute triangle. A triangle is called acute if all of its interior angles are acute, versus an obtuse triangle. An obtuse triangle is one in which one of the interior angles is obtuse. So consider this acute triangle, and right now I am considering the base to be this horizontal line AC. So then the height is this, the height I'm calling it H, and well, my base and my height are supposed to be perpendicular. Over here, I am considering the base for this obtuse triangle. I'm considering the base to be AC, and the height, well, it's also that perpendicular line right there. So consider the right triangle ADB. So ADB, or over here in this picture would be ADB, doesn't matter. In either picture you'll get the same thing. Sine of A, so sine of A is opposite over hypotenuse, so H over C, and then we solve for H, and now we have an expression for the height. Alright, and so one thing to think about here is that the height is relative to the choice of the base that you, yeah? So for instance, if I chose my base to be this side length C, well then my height would be some perpendicular line to it, yeah? If I chose my base to be side length A over here in this picture, then my height would be some perpendicular line to my base. So they're relative. So we usually think horizontal is the base, vertical is the height, but you know, that's just because that's how our mind works. We could also think about the base as being this length over here, and the height is going to be some perpendicular line going to it. So the height is relative to the choice of the base. And not only that, but we could have also drawn these triangles over here differently, and what we end up concluding is the following. We have some expressions for area of the triangle. So the area of the triangle can be expressed as 1/2 base times, and then the C sine A is just a height, or 1/2 base times height. That's what this is saying. And notice that in these three expressions for area, you have two side lengths and the angle between them. So side length A, side length B, and the angle between them. Yeah, that's why I wrote over here on this little margin SAS, because you have a side, the angle between the sides, so two sides and the angle between the sides. Alright, let's practice with this idea of finding triangles. Let's get into an exercise here. So I want to find the area of a triangle ABC if what I was given is the angle C, side length B, and side length A. And notice that right now what I have is two sides and the angle between them. So finding this area should be relatively straightforward. Let me think about which one of these three formulas for area I need to use right now. Well, I think I'm gonna have to use this middle one, because that's what I was given. I was given side length A, I was given side length B, and I was given angle C. That's the information that I have right here. So let's find the area then. I guess the area is going to be what? So my area is going to be 1/2 times AB sine C, which I guess in our case means 1/2. I'm going to put parentheses around things here. This is 35.1, and this is 43.8. That's my A, that's what my B is, and then sine of 72.2. Alright, and now it's just a matter of punching this into my calculator and being careful here. So let's see, what do I get if I compute this using my calculator? So 35.1 times 43.8 times sine of 72.2. Make sure your calculator is in degree mode, and all of that divided by 2. I get about 731.9 feet squared, because we're dealing with an area. Yeah. Alright, that's all there is to that exercise there. Let's think about the next exercise. I think this next exercise is a little bit more tedious. Again, give yourself a second here, pause the video, try to do this next exercise on your own, and then let's, once you've practiced with that, see if we can agree on the answers and the process. Alright, so how is this exercise different than the previous one? Well, what was I given here? I'm supposed to find the area of the triangle ABC if I'm given angle A, I'm given side length B, and I'm given angle C. So right now what I've been given is an angle, a side, and an angle. So our formulas over here, remember our little formulas for area, were very convenient if what you have is two sides and the angle between them. If you have two sides and the angle between them, then these formulas are pretty nice. But right now that's not what we have. We have two angles and just one side. So what should we do? I guess what we should start doing is completing this, getting as much information about this triangle as possible. I think the easiest thing to do here is try to find the third angle. So let's find, I guess in this case we need to find angle B. Well, that shouldn't be too hard to do. It's going to be 180 minus the sum, 59.8, and plus 53.1. Alright, that gives me 67.1. Alright, so I have at least now all of the angles and one side. All of the angles and one side. Well, let's think about our formulas for area. Our formulas for area require that we have two sides and the angle between the two sides. Alright, so I need to find, right now what I have is three angles and just one side. So what should be then the next what piece of information do I need next in order to find the area? What is the next piece of information to find the area? Well, definitely we need to find, either A or C. Yeah, I mean that's what's going to happen. Which one would make more sense? I mean, what's more straightforward, I guess? I don't think it matters in this case. If you find C, then you're gonna have to use B and C because you already know side length C. Or if you, I don't know, I guess let's just choose one. Let's find A. Okay, so to find A, what I'm going to use is the law of sines. And I'm going to say the following. I'm going to say sine of 59.8 divided by A should be equal to sine of 67.1 divided by 15. So right now what I'm saying is sine of A over A is equal to sine of B over B. Alright. So let me try to solve for A here. We've done this before, you know how to do this. Because what we're going to end up concluding is that A should be equal to sine of 59.8 times the reciprocal, 15 over sine of 67.1. And punching this into your calculator carefully and making sure that your calculator is in degree mode, you should conclude that this is about 14.1. I guess right now we're dealing with what are units here? Meters. So 14.1 meters. Okay, now think about what you have now. You have 3 angles now, and you have 2 side lengths, B and A. So now we have, well, I mean, we can, if we have the side length A and side length B, what's the angle between A and B? It's angle C. So I'm going to use this form of this form of the area in order to, well, find the area. So let's conclude this problem. So finally, area, I'm going to say that it's 1/2 AB sine of C, which in our case, I guess, is 1/2 times 14.1 times 15 times sine of 53.1. And if you punch that into your calculator correctly, you should end up with this 84.6, and I guess now we're dealing with meters squared. All right, a lot of information. Definitely practice with this idea of determining how many possible triangles can be made if you're given 2 side lengths and an angle opposite. That is a hard skill to sort of, it definitely requires some practice. Okay, so this is all for section 8.1. Next video we'll get into the law of cosines, and we'll tackle some other cases and some other situations. Alright, thank you. See you on the next video.